Hello everybody and welcome back. Root Beer here with question number 20 on our grade 7 Gauss paper from the year 2009. So let's take a look here. So question 20, each of triangle PQR and triangle STU, we look for them, they're very hard to see in our pictures, but there they go. There's one and there's the other. Has an area of 1. Okay. In triangle PQR, U, W, and V are the midpoints of the sides, as shown. In STU, R, V, and W are the midpoints of the sides. Oh, so we've got common midpoints here. That's pretty nifty. What is the area of parallelogram U, V, R, W? So this middle parallelogram, this middle diamond shape that they've got, we want the area of that. Okay, so let's copy the picture into our notepad. That way we can draw as much as we'd like on it. Okay, I'm not happy with that picture. I'm gonna draw a better one. At least I hope I'm gonna draw a better one. I have to do all of this by freehand. I don't keep a ruler near me. Okay. So we've got these midpoints here. This is looking much better, by the way. P, U, Q, R, R. It was S, then T, then V, and W. Okay. So, I know that both of these triangles have an area of 1. One thing I might do is drop perpendiculars. Okay? They're both going to have the same height, I would say. We don't know anything about these triangles in that they're isosceles or anything like that, do we? No, we do not. Okay. So my gut instinct tells me that if I just connect U and R, they'll be perpendicular, but as a more rigorous mathematician than, your average student, I'm hesitant to do that. It'll probably work out if I do it, but I don't want to do something that isn't technically true. What could I do? Well, I'm going to connect V and W. I'm going to connect V and W because that splits. We've got a triangle UVW, and we've also got RVW. Okay, so if I could figure out the sum of the areas of these two triangles, just add them up, and we'd be all set. And I think this is going to go well. So if you have a triangle, and this is a nice property, and you can generalize it if you do more geometry, if you're interested in that sort of a thing. But if I have two midpoints for my triangle here, and I connect them up, I get a smaller but still similar triangle. Okay, it's a very nice little property. Okay, if we added the other midpoint C in here, you could make the connection even a little bit better. But the idea is, if you connect up the midpoints, you get a smaller triangle. It's the same angle, and we get these side lengths are split in half. So this triangle, they're similar. So this is a smaller but similar triangle. And so the nice thing about similar triangles is their sides have a common ratio. So if this whole side here were x, this would be a half x because A is the midpoint. But that would tell you that this is a half of y, where y is this side. And if this side were z, we'd have 1/2 z. Okay? Now, there's another really nice property that hopefully you know. And if you don't know, here I'm telling you. If you've got two similar triangles, and you know the ratio between their sides, so in this case, x and then 1/2 x, that's a ratio of 1 to 1/2, the areas change as well by squaring. So, for our picture here, triangle UVW has an area of 1/4. Why 1/4? Because the side lengths of UVW are 1/2 the side lengths of UST, or UTS, and area squares. Okay. It's a very nice little geometric property. This keeps going. If I had sort of a three-dimensional shape that was similar to another one, and the ratio between the sides were 1/2, the ratio between the volumes would be 1/2 cubed. 3 for 3 dimensions. So that's pretty nifty. But I know that STU, or as I've written it, UTS, has an area of 1. So this part here has an area of 1/4. By the exact same reasoning, same ratio, same midpoint stuff, we get that RVW is similar to PQR, and so their areas are, again, the ratio between the sides is 2:1 or 1:1/2. We get 1/2 squared the area of triangle PQR. But we were told in the question that's an area of 1. So we get 1/4 times 1. So the area here is also 1/4. And now the area of the parallelogram is just going to be the sum of these two areas, 1/4 plus 1/4, or 1/2. I think I saw that as one of the answers. I think it was B. I'm not entirely sure. Yeah, it was B. Ah, fantastic. All right, so that does question number 20. There's some interesting geometry going on there. If you're not comfortable with similar triangles, or comfortable with, if you know the ratio between the two similar triangles, how that affects the area, then this question could easily be difficult for you. If you have another way to do it, I would love to hear it. This is just the first one that sprang to my mind. And so if you have another way, just give me a quick description down in the comments below. I'd love to know another way to do this question, perhaps even one that relates more to students in grade 7 or grade 6 or whatever age group you're at. Okay? But that does question number 20. Up next will be question 21. As we start part C, the questions are worth a little bit more, and they require just a little bit more work. Okay? I'll see you for that next time.